Hello everyone, today we're gonna talk about sorting, which is one of the most common operations in programming. But the real problems are never just ascending or descending order. Today we'll start from insertion sort and end with STL sort, focusing on multi-criteria sorting. And so let's sort courses over here in descending order without using STL first. And so insertion sort builds up a sorted region on the left side of the array, and at each step we take one element and move it left until it reaches its correct position. And so we compare backwards. Basically we compare backwards because you know the correct place is always somewhere in the sorted part. If the order is already correct, we stop early, which makes insertion sort efficient for nearly sorted data. And so I'm going to show you how it works. Well, I'm going to take 72 as the first element, but we don't have anything to compare with 72 because it's the first data. And if we take 88, and we're going to sort it in a descending order, and then we compare it, two of them, and then we need to swap it to make this a descending order. And then we don't need to, we're not allowed to compare anymore because this is the first index. And if we um, access this point, it will be index underflow, which causes the error. And let's take 65. And as you can see, it is already sorted in the descending order. So we don't really need to compare, or we compare it, but we don't really need to swap each other. Let's take 90. We need to swap it, and it's going to be 90 and 65. Compare with 90 and 72. We need to swap it as well. And in this case as well, we need to swap it. And so let's take 81. Well, we need to swap it, and we need to swap it over here as well. Well, if you take a look at this part, it is 88 is greater than 81 already, so we don't really need to swap each other, so we stop here at this point. This is the key point of the insertion sort. And let's take 70. We need to swap it because 65 is the smallest one. And 72 is greater than 70, so we ends here. So if you take a look at the final data in this array, it shows the descending order, as you probably can tell. So is this is how the insertion sort works. Well, first things first, I'm going to copy and paste this array and write down the basic code first. Well, we need the array of sorted array with size of 6. And in the end of this code, I'm going to print out the sorted array. Check the result. Well, we need to repeat 6 times for the outer loop. And we need to copy the element from score array like this. Well, when it comes to I0, there is no need to compare with this element. So we start from I, but we don't include 0 because it can cause the index underflow, but still we can compare with the element in index 0 using this kind of technique. Like this, we still can compare with the element of index 0 and index 1 when x is 1. And so if if this result of this operation is true, we're going to swap it because we're going to order in the descending order. Otherwise, we're going to end this inner loop because, like I said before, if the order is already correct, we stop early, which makes insertion sort efficient for nearly sorted data. And I think this is the all about coding part. So if I execute this file, well, 90, 88, 81, 72, 70, and 65, which is the descending order. But if I change this direction, it is ascending order, as you probably can tell. So this is how the insertion sort works. Well, let's move on to the next example, which is multi-criteria sorting. And so the first priority, the top priority, is the odd numbers, and then even numbers later. And if both numbers are odd or even with the same type, we're gonna take the descending order for the second priority. So if we take a look at this array example, well, since the odd number is the top priority, 971 is the odd number, but those are the same type. So we need to take the descending order, which is our second priority. And the rest of them, 4, 2, 6, 8, is the even number, but those are the same type. So we're gonna take the descending order. So 8, 6, 4, 2. So the result of the sorting with the multi-criteria sorting would be like this. So I'm gonna show you in Visual Studio as well. Well, I'm gonna copy and paste this already. Well, I'm gonna print out the result array in the last part of this code. We need a result array with size of 7. And in this case, we're still not going to use the sort STL library. So we're going to use the insertion sort as well. I'm going to copy the element from the array. And for the inner loop, it goes backward, starting from I. And we're not going to include 0 because it caused the index underflow. And I'm going to compare the result x minus 1 and result x. And I'm going to make the priority compare function. And if this result of this function is 0, I'm going to swap it. Swap the 2 of this element. And otherwise, I'm going to break it. The end this inner loop. we need the two parameters. And like I said before, it should be odd number first. Otherwise, it is descending order. And so if A is odd number and B is the even number, we don't need to swap it because that situation is our top priority. But in the opposite situation, this is the worst priority for us, so we need to swap it. Otherwise, it should be a descending order. And so if A is greater than B, we don't need to swap it because that is our second priority. Otherwise, we need to swap it. And so I think this is all about the coding part. So if I execute this file, 9718642, like we expected already. 9718642. There we go. Well, with the same situation, I'm gonna use the SDL library in this case. So we need to include the algorithm, and we need to write down the basic code first. I'm gonna sort it with the array. And we have 7 elements. And I'm gonna name the function as PC, which stands for priority compare. And in the last part of our code, I'm gonna print out the array. And I'm gonna make the priority compare function with the bool type, but if you want, you can make this return type as integer. It's up to you. And if A, which is our left one, is odd number and B has even number, this is the perfect situation that we really want. So I'm gonna return 1. Oh, it's gonna be true, but for the integer type it will be 1. And if A has even number and B is odd number, this is our worst case scenario, so we need to swap it. And if both numbers are same type, both are even or odd, we need to follow the descending order. So if A is greater than B, which is already the descending order, so we're gonna return true, which means that we don't really need to swap each element. Otherwise, we're gonna return false. And so if I execute this file, 9718642, as we expected, the result of this code is exactly the same compared to the previous one. But in this case, we use the SDL library in the algorithm library over here. Well, this is our last example for today. First things first, there is 3 different kinds of priority, but the top priority should be the higher level first. And if there is the same level, we're going to sort out depends on the score. So it should be lower score first. And lastly, if the level is the same and the score is the same, we're going to sort out with the name in the alphabetical order. And so I'm going to copy and paste this data. I'll just write down the basic code first. we need to include the algorithm. Well, in this case, we need to make the structure. I'm going to sort out array, and I'm going to name the compare function with the bool type. We need to node A, node B. There is the level, score, and character type name. So the first priority is the level. So if level are different, we still can compare with the level. So if A level is greater than B level, it's going to be true. We don't need to swap those things. Otherwise, we need to swap it. And second priority is the score. If the score are different, and if A score is lower than B score, this is what we want. So I'm going to return true. Otherwise, I'm going to return false. Well, for the last priority, at this point, A-B level will be the same, and A-B score would be the same at this point. And so we need to compare the name with the alphabetical order. So if the name of A is greater than the name, we need to swap it to follow the alphabetical order. Otherwise, I'm going to return true. There we go. And so I'm going to check the monitor. Well, as you can see, the level, basically it is sorted out with the higher level. And if the level are the same, it is sorted out with the lower score. And if the score are the same and the level is the same, it is the alphabetical order, as you can see. And so it works well. Yeah. So this is all about today's video, and I hope you find it very useful through this video. Thanks for watching. See you on my next video. Bye guys.